at Veridise, we've looked at a number of different languages and ecosystems that people develop smart contracts in, which helps. But we've also looked at a number of different applications that people have built using smart contracts on the blockchain. And so this has given us a lot of experience identifying bugs. But on top of that, a lot of us at Veridise have performed academic research and published papers about tools to identify vulnerabilities in smart contracts. And at Veridise, we've continued that work. And so in the process of building tools, we've needed to make sure that we understand the language and the ecosystem well to identify these vulnerabilities. All of these tools have also been integrated into Audit Hub, which is a platform that we use in order to facilitate the auditing process. And so during the audit, not only do we manually inspect the code with our team of fantastic security analysts and engineers, but we also use those tools in order to identify vulnerabilities in your code automatically. At Veridise, we've audited across a number of different ecosystems and languages, including Solidity and Viper, as well as Rust-based languages like Solana or Soraban, in addition to ZK languages like Alio and O1JS and Noir. And so we've had a lot of experience seeing exactly what can go wrong when interacting with a blockchain in all of these different ecosystems. And we've kind of distilled that into the types of bugs that can go wrong no matter what you're interacting with, and as well as the types of bugs that are specific to individual ecosystems. The most common bugs that we find in smart contract audits are logical vulnerabilities. So these are just vulnerabilities in the actual business logic of your smart contract. And so they are unique to your smart contract, and they can occur in things like your accounting as you track funds that come into your smart contracts. They can occur in other behaviors like liquidations. And so pretty frequently those bugs are significant, and they can have a dramatic impact on the actual behavior of your smart contract. Other bugs that we commonly find are missing data validation. So for example, anyone can provide you with data because pretty much anyone can interact with your smart contract. And so for that reason, you need to make sure that you control not only the people that are interacting with your contract or who you want to interact with your contract, but also the data that they're providing. And so in many cases, we found values that could be provided or people that can interact with your smart contract that the developer doesn't anticipate. The final thing that we found quite frequently, or the final thing that I'll talk about that we found pretty frequently, are denial of service errors. And so this occurs when your smart contract can be forced into a state where it can no longer make forward progress. So essentially a user could be stuck with their funds in your contract, or your contract itself cannot perform some behavior that it should be able to.